So now this is the extra lesson, which is 2019 second semester for 10th graders to prepare for the first quiz. Let's put this one in down there. So now I shared the papers in this site. Everything you need is in there. When you open 10th grade, you will see quiz questions, and these are the lesson documents. Now we are doing the last one. We are doing this last one. In this last one, how many pages did we do? We did finish until here. You see, I didn't put the other one that we started today. I didn't put. But until here, you are responsible with that. So now, I am starting from first page. I think you didn't study yesterday, did you? Anybody studied yesterday? It's very bad.
Yes, I.
Very good, very good then.
Saturday and Sunday.
Very good. So now, let's start with this kind of examples. These are very basic examples. Let's start with this second one over there. How can we make this second one? Do you want to try, or should I directly start?
Directly start.
Okay. So now, here we have bases and powers. We should show each base as power of a number. Now number 4, the base 4, can be shown as 2 to the power of 2 to the power of 2. Instead of 4, I write 2 squared. So then the other power, we just copy it down. So minus the 32 can be written as 2 to the power of 5. So instead of 32, I write 2 to the power of 5, and the power 3 over 5, we just copy it down there. So plus, this is the important one. 27, normally 27 is power of which number? 3 to the power of 3. But right now I have minus 27. Can I get minus 3 to the power of 3? If I do it like that, I can get that as minus 27. Let's put it there. Minus 3 to the power of 3. This is the part only for minus 27, but we have another power over there. Let's change the color so you can see the idea. This is only for minus 27, then power 2 over 3, you copy it down. So now after you change the bases with exponential notations, it is time to multiply power by power. Remember that there was the property when you have 3 to the power of 5, you can easily multiply those two powers and say that it is 3 to the power of 20. So now in here, 2 to the power of 2 times 3 over 2. 2 times 3, 6. 6 over 2 is 3, but it is minus. So this minus is between them, I just copy. Now I am calculating for the mid part. 5 times 3, 15. 15 over 5, 2 to the power of 3. Now I am calculating for the last part. The base is minus 3. We can't change the base. 3 times 2, 6. 6 over 3 is 2. It is time to calculate. So let's calculate each of them. When you have negative power, you cannot calculate directly. You should make it positive power by putting it down. 2 to the power of 3. What's that? 2 to the power of 3 as number 8. Minus 2 to the power of 3 is 8 also. Then minus 3 squared is plus, let's work, 9. So 9 minus 8 makes 1. Right now actually we have the calculation 1 plus 1 over 8, which simply can be shown as 1 and 1 over 8. Or if you make it, you can write in here 8 over 8 instead of 1. 8 over 8 equals 1. So 8 plus 1 equals 9 over 8. Both of the answers are true. So one of students wants me to solve this question. So firstly, let's go to the basics. Which is, let's remember the idea of this rule. If you have 5 square root of 3, And to make some calculations, if you need to put 5 inside the square root again, if you need to put this 5 inside the square root, how do we do it? Square root of which number is 5? 25. When you put it inside, you make it 25. Actually, you are taking square of it. For example, if I have cube root of 4, let's change this number so you don't mix what it is. When there is cube root, let's say to make some calculations you must put it inside back. So you think for the 4 it's already inside there, to put 5 in there, so cube root of which number makes 5, which is 5 cube. Don't have to memorize 120, which is 5 cube directly. If there is 5, 7th root of 2, how do you put 5 in? There should be 7th root again. 5 power 7 and times 2 already inside there. This is the idea 1. Do you remember this one? This is easy. No problem. When there is square root, to put inside, make power 2. When there is cube root, make power 3. It's very simple thing. So now the second property you should remember in here, if you have cube root of square root of, let's say, a to the power of 10. I want to remove this a to the power of 10. Like, right now it is divisible by 12, but anyway. So, I don't want two radicals in there. I want just one radical so I can move it easily. I can change it easily. Which is, there is degree 3, nothing else between them, degree 2. So you do it like the radical expression 3 times 2, a to the power of 10, staying inside. It was already inside of all of them. So you connect these two radical expressions by multiplying their degrees. So it will become 6th root of a power 10. Let's say I have 5th root of square root of 2 to the power of 7. So how can I connect them? 5 times 2, which makes 10th root of 2 power 7. It was already inside. So now, actually in this question, I want you to write them all as exponential numbers. Let's go back. Simplify the expression. So simplify the expressions. We can write them all with powers like we did in here. After we write powers, some powers will simplify each other. Then we have some calculation. We have some result. So now, look at that. I have too many roots a's inside. So I want to make just one single thing. Just one single thing. So the first thing that I should do, which is I want to connect these two radicals, but a is problem in here. I cannot connect them. When there is something else, I cannot connect. So firstly, what should I do? I'm gonna put a inside the smaller one. I'm gonna put a inside the smaller one. Do you understand this? Like the other one with numbers. So I write all other things same, square root, a, cube root. Now I'm gonna put this a inside other one. So there was this a, it won't be anymore in there. So the other a, it was already in there. So now the one that I am going to put, when I put it inside the square, it will be a power 2. So right now, since there is nothing between these two radicals, I can connect them as a single radical expression, which is I write other things again. Square root, a is staying there. So now these two radicals will be, just one, which is 3 times 2. Very good, quickly. 6. What will happen inside them all? A to the power of 2, a to the power of 1 will be a cube in here. So now I want to connect these two as well. I connect, but a is the problem. So what do we do? Similar process. You put the a inside. Then there will be square root in the beginning. A will be gone, and after square root we have 6th root. So I'm gonna put this a inside as a to the power of 6. This is right now I have 6th root. Remember from here, when you have 7th root, when you put it inside 5 power 7. So it's going to be a power 6 when you put that inside, then times a cube, it was already inside all of them. So now, since there is no more thing in here, I can connect those two as square root, 6 root 2 times 6, 12. What will happen inside? So now we go back to the exponential idea. So normally we divide power by degree to be able to move it out. But right now 9 is smaller than 12. So to be able to move it out, I write it like a rational expression. 9 over 12. 9 should be divided by 12. So then if you simplify 9 and 12 by 3, it's going to be a to the power of 3 over 4. It is kind of like when you have square root 2 to the power of 8. How can you put it out quickly? 2 to the power of 8 over 2, 4. If you have cube root of, let's say 5 to the power of 12. How can you simplify it? 12 divided by 3, 5 to the power of 4. Actually, we are doing the same thing. We cannot divide 9 by 12, I mean without remainder, but we can write it as a rational number. So then you simplify it, so this will be the most simplest form. Until here it's enough for me in exam, but if you have this question in somewhere else, like your matura exam, they will give you in this way. So they will make another radical. The one in denominator, it is radicals degree. 4 is in here and 3 is in there. They will convert back. Denominator goes to degree of radical and numerator goes to power of the number. But till here for me it's enough in exam. So let's pause this video. Question. So now one of the students asked the question D. You can pause the video and try to solve it by yourself. So then after you try, listen to me. Pause the video right now. I did like that. So now let's solve this question. In this question we will use the idea in the next page that I did right now, which is this one. We will convert it to exponential form. So the power from inside goes numerator, the power from here goes to denominator, 3 over 4, divided by 81 is 3 to the power of 4. So this is actually 5th root of 3 power 4. So it will be 3 to the power of 4 over 5th root. So then times 27, actually it is 3 cube. This is square root. So how can I convert it? Power goes to numerator, degree goes to denominator. Did you understand? Right now I only converted them into exponential form. So I can make calculations. So right now we have two calculations next to each other. This is something like 5th grade thing. You know, you should have learned this in 5th grade. Let me write a question for you. This one. 24 divided by 6 times 2. If you have an expression like this, which is division and multiplication, they are similar kind of calculations. You go from left to the right. So firstly you do division into 4, so then times 2, 8. But if you do it inverse, firstly times, which is 12, then divide, the result will be 2, which is false. So now I am going to do that. Firstly, I will use the operation of division in here. When we divide exponential numbers, what do we do with powers? For example, if you have 3 to the power of 4 over 3 to the power of 2, what do you do with the powers? What is the result? Do you remember?
3 power
2. What is the calculation now? 4 minus 2. 4 minus 2. For example, if there was 5, 5 minus 2, 3 to the power of 3. So we subtract the powers when there is division. So I should subtract the powers. 3 over 4 minus 4 over 5. So then I have 3 times 3 to the power of 3 over 2. I just copy it down. So this will be the result of division. But I don't want to calculate it right now in here. So I want to do the multiplication. If you are multiplying like 3 squared times 3 to the power of 5, what do you do with the powers? 3 to the power of, 3 to the power of 2 plus 5. You add the powers. So right now I'm going to use the calculation times, which gives me, I should add this power, which is 3 over 4 minus 4 over 5. I should add 3 over 2 to this one. So this will be the final result. So to be able to calculate the final result, I should calculate this somewhere else. Let's clean the left part. Let's not do it with on power part because I have to write them small. Let's do the calculation somewhere else, then write it back to here. So the calculation 3 over 4 minus 4 over 5 and plus 3 over 2. I should calculate this. To be able to subtract at the denominators, they all must be same. Let's take multiples of 5. 5 times 2, 10. I can make 2 times 5, 10, but 4 times, then 15 not working, then 20 is working. I can make 4 times 5, 2 times 10. So I can make them all equal at the number 20. So to make 4 into 20, I should enlarge this by 5. 5 times 4, 20 will be 5 times 4 I need, 2 times 10 I need. So I am going to enlarge each fraction. 5 times 4, 5 times 3 is 15, 20 will be down there. Between them minus 4 times 4, 16, 4 times 5, 20. Between them plus 10 times 3, 30, 10 times 2, 20. So right now all the denominators are same, so I can add the upper parts. Firstly, 30 positive, 15 is positive. 30 plus 15, 40, 45. Minus 16, 45 minus 16. 45 minus 15 is 30. Minus one more, 29. 29 over 20. Can I simplify this? No. So it is the result. 29 over 20 is the final result of the real example. It was just additional calculation in the right side. So now the people in here, they wanted me to solve this question. Okay. So here we have two important things, which is constant polynomial and zero polynomial. Zero, let's change it to the pen. Constant, zero. Constant polynomial means that when I write polynomial, normally there would be x to the power of 5 minus 7x to the power of 3, something like that. Constant polynomial means that there is no x, it is just equal to a number like 5, or it is just equal to a number like 10. We don't have any other thing, any more x things over there. So then zero polynomial means that there is no any x value in here, and even the number itself in here, px, even the number itself over there, the number part is also equal to 0. There is no other things. So right now, in here, this is the rule given to us. In this rule, I have x cubed, so I should kill the x cube. I should eliminate it, x cube. How can I do it? By making x cubed times 0 to make it a constant polynomial. There is x. To be constant polynomial, there mustn't be x. So I should remove it from there by multiplying 0. This part should be 0. This part should be 0 also. What about the last one? Plus 15. When it is constant polynomial, it can be equal to a number like 15. So having 15, no problem for us when it is constant. But when it is zero polynomial, also 15 cannot be there. We should make it 0 somehow. So right now, this one, x cubed times 0 must be there. 3a minus 6 is equal to 0. 3a equals 6. a equal 2. So then 5 minus b equals 0. So 5 equal plus b, if you put minus b in here. First question finished. Now second question. Says that it is zero polynomial. So everything should be equal to 0. We cannot give numbers instead of x. We can give different kind of numbers instead of a, b, c, because x is something like unknown. For example, I give you a function like or a polynomial like x plus 2. X is always in there. Actually, we cannot put. So we just try some numbers with x. We don't, x doesn't affect the polynomial itself. So for example, I ask you to find P0, P3, P7. So x is a changeable value. But the others, and these are like some constant numbers like 5, 7, should be put in there to get a polynomial like this. So I want to get a polynomial like px is equal to 0. So instead of n, if I put 1, 2 times 1, 2. 2 minus 8 minus 6. It will be like polynomial equal minus 6x to the power of 4. I don't want this to happen. So instead of n, what kind of number should I put? So there mustn't be x power 4. So I must make it equal to 0. 2n minus 8 equal to 0. Like you said, minus 8 other side, so n equal 4. This is the algebraic showing how to find the 4. So now, when I write, instead of right now, n is 4. Instead of n, if I put 5, 4 minus 5 is minus 1 plus 2 is plus 1. So there will be 1 times x squared. So I don't want 1 times x squared. So all the things before x squared should be equal to 0. N minus m plus 2 should be equal to 0. So now we found that n is equal to 4. And minus m plus 2 equals 0. Put minus m in here. 4 plus 2, 6. And done. What a simple question to ask in quiz exam. Let's start. Now the people in here, they wanted me to solve this kind of questions. It was a bit mixing your minds in the class. So I'm gonna make another type of question. Let's say this is for exam. How can I change this question? What was that? Find P if, tamam, haydi bakalım. Right now I am writing the question for exam. Find P of 3x minus 1 if P of x plus 1 equals, if P of x plus 1 equals, let's say 4x minus 2. Look, in here the rule is given for x plus 1. Inside the parentheses I want to get 3x minus 1. So since they are same letters, it can mix our minds. So I should find in this polynomial, in this one, instead of x, what should I put so I can get 3x minus 1? That's why I changed this 3x minus 1, something like find 3a minus 1. So our minds, we don't mix what to do. So inside the parentheses, actually right now there is x plus 1. And I want in there, what do I want in there inside the parentheses? 3a minus 1. So inside the parentheses, to get 3a minus 1, inside the parentheses, instead of x, what should I put? You move plus on other side, so it becomes x is equal to 3a minus, it will be minus 1. Minus 1 minus 1 minus 2. Instead of x, then you put 3a minus 2, that means inside the parentheses, it will be 3a minus 1. Let's show it in another color, so the people who watches. When you make the changing, this expression will be inside the parentheses, which is, instead of x, put 3a minus 2. Instead of x in here, put 3a minus 2. Then there is another plus 1. Equal 4 times, instead of x, what am I putting? 3a minus 2 with parentheses, and another minus 2 is in there. So minus 2 plus 1, it will be p of 3a minus 1. 4 times 3, 4 times minus 2, minus 8 minus 2 makes minus 10. Let's go back to the question. What does it want? Find P of 3x minus 1. But I found P of 3a minus 1. So, for the question, for the sake of the question, normally we don't have to, we change a back to x. So it will be the answer that they want from us in the question. I hope that you understood this one. Let's follow. So now we will solve this example from the PDF that I gave to you from the site. First you pause the video, try to solve this question without checking from your notebook on your own. This is a very important question type. I can put this question in both of the places, in exam, in quiz, because this is very important. This is new to you. You have learned how to multiply, how to add when you were in 8th grade, 9th grade. You did too many times. But this is the first time that you are doing how to divide them. So now, let's start. Firstly, we write this polynomial in there. Same again, 6x cubed minus 11x squared plus 13x minus 7 will be divided by this, will be divided by 2x minus 3. So, it's all about the big one, biggest one. Big and the biggest should be exactly same. I will multiply 2x with something. So when I multiply 2x with that, it should be same with 6x cubed. So 2 times 3 I need. So it will be 6. So x times x squared I need. So it can be x cubed. But when you write 3x squared in here, you multiply it by 2x. You also need to multiply it by minus 3. 3 times minus 3 will be minus 9x squared. 3 times minus 3 is minus 9 and x squared from here. X squared from there. So after we multiply, it is time to subtract them. I will subtract these from up. But when I subtract, it's kind of, remember from the class, is kind of like 6x cubed minus 6x cubed minus 9x squared. So this minus will change the sign of both of them. 6x cubed minus 6x cubed minus minus plus 9x squared. Because of that subtraction, the sign of both of them will change. So we do show them in here smaller. Minus times 6 will be minus, minus times minus will be plus. So from now on, I won't care about this minus in here. I will calculate it as it is plus 9x squared. Okay? So 6 minus 6, 0, minus 11 plus 9 minus 2x squared. I finished the subtraction, so I move on by moving the other things down again. So right now, here we have a result. The biggest one in here, the biggest one in there. So I should multiply 2x with something, so it should become minus 2x squared. So 2 times minus we need, minus times 2 will be minus 2. Then x times x we need, so x times x will be x squared. So after you decide this as minus x, you should also multiply it with minus 3 in here. Minus times minus will be plus, x times 3 will be 3x. So it is time to subtract. The multiplying finished. Yes, you can come. So now, because of the subtraction, the signs will change. I am going to write their new signs, which is minus times minus will be plus, minus times plus will be minus. So now I am going to calculate with their new signs. Minus 2x squared plus 2x squared, 0. Minus 2 plus 2, 0. Other side, plus 13 minus 3 makes plus 10x. We just move 7 down. There is no calculation for it to make in here. So now, subtraction finished. We check one more time. The biggest in here, the biggest in there. So can I make 2x into 10x? Can I make it same? So 2x times what should I need? 5. 2 times 5, when you do 5 times 2, it will be positive 10. So it's already x, so x will come here. I don't need to put any more x in here. Because if I put x in here, x times x will be x squared. We don't need x squared, we just need 10x. So 5 is the right number. So after you multiply 5 by 2x, you should also multiply it by minus 3, going to be minus 15. Multiplying finish, it is same process again and again, we repeat it. So now time to subtract. So when you subtract, this minus will change the sign of these two things. Minus times 10, minus 10. Minus times minus 15 is plus 15. So plus 10 minus 10, 0. Plus 15 minus 7 plus 7, 7 is 14, 8. Plus 8. So now the biggest in here 8. The biggest in there 2x. Can I multiply 2x with something and make it just 8? If I multiply 2x by 4, 4 times 2x will be 8x. So we cannot do it, which means that it is finished. 8 is the remainder. So now we will continue with this example. I've changed the question a little bit from the PDF. It can be your quiz question. This is your quiz question. So here is the idea. Remember the question that I solved in this video, the previous question. I was dividing it with, what was that? 2x minus 3. If you are dividing it with 2x minus 3, at the end, let's say I have 5x minus 4. I can still 2x into 5x, I can still make it like I multiply 2 by 2.5 and make it 5x. Later, the result, the remainder should always be a number. The result should always be a number. There is no more x, there cannot be any more x. Because if you are dividing it like 2x minus 3, x plus 2, if you are dividing something like that. So now, I should divide px by qx, x plus 2. We don't care about the result. Let's say there is a result like x, mx. So we will do lots of process in here. We will find the remainder as a number. We will find the remainder as a number since this is first degree. X power 1, 2x plus 2, 3x minus 5, anything, just x. There is no exponent. So how can I convert this expression into equation? The biggest one, px, equal to x plus 2 times the result and plus r more. So I want to find only the r. I don't care about the rest of this part. Check that. If you put minus 2 instead of x, what happens? P of minus 2, it will be minus 2 plus 2, 0 times m of minus 2 and plus the remainder we don't know. 0 times m of minus 2 will be 0, which means when I put minus 2, it will be equal to remainder directly, because all of the other parts in here, the mx, x plus 2, they will all be gone when I put minus 2. So this is the understanding part of it. Now, how do you do in this in exam? How will you do? You will write on the right side. You will say that x plus 2 equals 0 when x is equal to minus 2. Which means when you put minus 2 in real polynomial, it will give you a remainder directly. You will write it in here. P of minus 2 will be equal to remainder. So which is P of minus 2. Let's put minus 2, 2 times minus 2 power 4 plus 4 times minus 2 power 2 minus 5 times minus 2. So P of minus 2 is equal to remainder. Now I will find remainder. Minus 2 power 4. There is even power, shift power, so it will be plus. So 2 power 4, 2 times 2, 4 times 2, 8 times 2, 8 times 2 is 16. 4 times 2 minus 2 squared is plus 4. Minus times minus plus 10. So let's make it 32, 16 plus 10. 2 plus 6, 8, plus 0, 8. 3 plus 1, 4, plus 1 more, 58. 58 is the remainder. So we didn't have to go all this way in here. You don't have to make normal division to find the remainder. But if I tell you, divide them, you should make this process, all of it. You should show me all of it. But if I ask you to find only remainder, find the remainder, this is the quick way. Huh? So now, these two types of very easy questions, these are. divisible by or is a factor means the same thing. Can you tell me a factor of 12? 3 times 4 is 12, so 3 is a factor of 12. So, also 12 is divisible by 3. What does it mean? When you divide 12 by 3, no remainder. No remainder. So, I want to find the n in the polynomial. I want to find the polynomial, all of it. So, instead of n, what number should I put? So, x plus 2 can be a factor of px, this polynomial. What number should I put? Which means that we will do it like we are trying to find the remainder. When we try to find the remainder, what do we say? When we divide px by x plus 2, remainder is 0. So, to check the remainder, you make this one equal to 0. You say that when x is equal to minus 2, when I put this in polynomial, it will give me remainder. When I put p of minus 2 in polynomial, it will give me remainder. Since it is a factor, the remainder is 0. So you will just put minus 2 power 5, minus 3 times minus 2 power 3 plus times minus 2 and minus 2, plus of minus 2. So you will just calculate these ones and find it will be equal to 0, continue. Same idea. You will say x minus 3 equals 0, when x is equal to 3. This, when you put 3 instead of x, p of 3 will give you the remainder. Since it is divisible by that one, the remainder is 0. No remainder, means it is 0. So in the right side, instead of x, you will put 3, and by putting 3, you will find the k. Let's pause it, yeah. So now this must be the last question of the extra hours, since we don't have so much time. And in here, I will firstly take you back to the class. When we want to factorize this kind of expression, what do we do? Firstly, we look for number parts. 5 is common. Then we look for the letters. X cubed, x squared is the common. So we put x squared out, smallest power out. So from here, 20, from 24, from x cubed, 1x, 4 of them out. So from 53, x squared, all of it out, and that. In here, since there is just x, there's no numbers in here, I will look for the smallest power. What can it be? Actually, there are several ways to make it like that. You can say that m plus 2 should be smaller than 2m plus 1. Or if we check for the m part, so in 1m there are 2m, so I can put 1m. There is plus 1, there is plus 2 and plus 1, so I can put m plus 1 out. So from here, there was x to the power of n out, plus 2 out, plus 1 out, so there remains only power 1 in here. And plus x to the power of 2m means like m plus 1. 2m means, so we put 1m and plus 1 out, so there remains only x to the power of m. So we factorize it. Or you can do like that. Let's say you want to put x to the power of m plus 2 out, m plus 2 out. Which means you will move all of the first thing out, so you will write 1 for it. In here, in the power, I should write something, such that thing, so when you multiply it back, when you open it back, it should be equal to 2m plus 1. Here I have 1m. To make it 2m, I need another m in here. Here I have plus 2. To make it plus 1, I need minus 1 in there. Which means, so I wanted to see the real process. If I do this calculation back, to open parentheses, I should multiply everything with this. X to the power of m plus 2 times 1, x to the power of m plus x to the power of something times x to the power of something. So, which is in the same base, you add the power. Power from here, m plus 2, and plus power from here, m minus 1. So when you add all of those things, m to m plus 1. This was the last question for extra hour. If you need any more help, you can write me from Viber group. I can take some videos and send you out of the YouTube. I wish you good luck tomorrow for the quiz. Let's